So this topic this morning still, just before lunch, is about dancing services. And it's a little dive into a project we're doing with Trifork. And the technology we're using is Axon. So we have here together with myself, I'm from Trifork, and we have Frans from Axonic. And we will give this talk, and hopefully we'll have a good presentation for you guys. So we have three topics. Dancing services. We're going to switch now and then. So hopefully that's going to be it's going to work out interactively nicely. We're going to go into some patterns, what we see in terms of architecture and how to build microservices on top of Axonic or Axon in general. And then we'll have a look at some operational aspects, the way we actually we have our CI/CD configured and how we actually run the application on the cloud in Kubernetes. We'll dive into that. Frans, you want to introduce yourself?
Yeah, so I'm Frans van Buul. I'm an evangelist at Axonic, company behind Axon Framework, which we will be introducing as part of this presentation as well.
Yeah, my name is Christophe Bouillet. Software architect with Trifork, and I like to work on mostly on complex distributed software architectures, and that's what we were actually allowed to do in this case. Now it's your turn, I believe. Yeah.
So anybody here like me who did service-oriented architecture and SOAP and WSDL last decade? Anybody frustrated with that? Yeah? Yeah, so was I. So back then, like more than a decade ago, this concept of orchestration versus choreography was also already something that you would find in the literature. And I think nobody of us wants to go back to that time, but actually this concept is also really useful in the more modern microservices architecture. So what we want to do is kind of bring back this distinction between orchestration and choreography, have a look at it again, and see how we can apply it today. So orchestrated architecture is essentially architecture that's very much akin to how a musical orchestra operates. And so some of the key characteristics is that there is a very clear leader called the director in the context of an orchestra. And the musicians, they don't make their own individual decisions. They can't just decide what they want to play. They will respond to the commands executed by the director. So the orchestra as a whole plays a certain melody, and it's doing that by composing the individual instruments being played by the musicians. So if you translate that to a services architecture, what that's kind of like is that a big, large-grained service gets the original request coming in from a user, and this gets distributed to multiple layers of ever fine-grained services that will execute it. So you do a lot of service composition, so services playing compositions, which is also a musical analogy in a sense. So one of the theories behind this, the theory that made this seem like a good idea, is that you would be able to reuse these fine-grained services in other contexts. So if you were going to build a next application, different from the original one, you could still reuse some of that code that you had already written for the first one. It was very much a theory. In practice, didn't really ever work out. And that was because there were some really key downsides to this architecture. So first of all these layers of composition introduce delays, especially if you use a very heavy protocol like SOAP to do that. You're not really going to be happy with the performance of this application for the end user coming in through that front end. It also tends to be unresilient. If you have lots of synchronous coupling between all those services, if one goes down, then probably all the services that depend on it will not function anymore. It's also highly non-agile. So one of the promises of microservices architecture is that you should be able to switch a single microservices into a new version, getting new functionality for the end user, while not having to change everything. And that's obviously not the case here. So if you want to have new functionality in your front-end system, you're going to need changes on the different layers as well in order to actually make that work. So there are some reasons why building up complex services architectures like this with orchestration never really worked out that well. So enters choreography. So choreography is not thinking about this like a musical orchestra, but thinking about it like dancers. And there are two key differences between how dancers collaborate to have a single show versus how an orchestra collaborates. So there's no clear hierarchy. There's no conductor in dance in general. And those individual dancers are autonomous. They don't work isolated. They look at their environment and they respond to their environment, but making their own decisions. So it's much more loosely coupled. So this is something that was already discussed quite a lot in the SOA era, like a decade ago, but wasn't really getting implemented that much because we lacked the technology to do it properly. Right now with microservices, it's coming back and it's really working very well. And Christophe is working on an application that actually does that.
Which is Blocks, Enters Blocks. Anyone heard about Blocks or We Are Blocks? Yeah, some colleagues in the back and some colleagues in the front. So yeah, hopefully, and I'm pretty sure that's going to happen, you're going to hear much more of it in the coming, let's say, between now and 6 months. There's going to be Blocks is more than actually a new brand on the Dutch, and later on expanding into other countries in Europe, even going internationally. One of the founders, Vince Meens, which is quite a well-known visionary person, he actually calls it, he doesn't want to call it a brand or a new product on the market, but he calls it a movement, right? And Blocks refers to blockchains. And the idea behind the Blocks platform is that we can actually build a platform which will interact with all kinds of blockchains, also interact with traditional financial systems, banks, and also interact with all the existing current crypto exchanges out there. So think about, well, actually that's my next slide, where you can actually see that we have these connections to these external domains, crypto exchanges, blockchains, and fiat networks is a term in the financial world for banks. And then you will have broker applications, which can actually, so it will have an open API where you can actually get market information about currencies or other blockchain tokens. We actually tend not to talk too much about currencies because we see blockchains at the end of the day as a mechanism to exchange or to do transactions with tokens, but what the tokens mean and what the underlying contracts mean can be quite open. But the initial application will definitely be trading, so buying and selling cryptocurrencies. So if you look at the domain, it's very, it's by nature, it's actually event-driven. Stuff happens, right? We have, obviously we have requests coming from the broker apps, but we also have things happening on the blockchains, you know, polling addresses, so we have transactions happening, we have transactions happening on the traditional bank networks, so we have, for example, money coming in. On the crypto exchange, a lot of stuff happens. We receive order books on a permanent stream of exchange order books. And we do a lot of things with that. Another requirement is really that it's, there's a lot happening, right, in this world, so we want to be very agile. We want to be able to deploy new functionality, new modules without interfering into what's already running. And on top of that, it needs to be super scalable, super large. And I personally have experience, and it's always, I mean, you read quite often that you should start small and then revisit your architecture when your user base grows after so many users. Actually, I think you even advise, if you start using Axon, to start with a monolith. And we didn't follow that advice. We actually started distributed from the start. So we decomposed actually the system. I will tell a little bit more about that later on. And then we have also, when it comes to performance, low latency, high reliability, all the, you know, the 5 nines reliability you want to have in your system. So quite a demanding architecture, and we felt that Axon and especially the Axonic, which Francois will highlight later on, products like AxonDB and Axon Hub were a very, very good fit for this application. And now we move into coding patterns. I'll hand over to you.
Thanks. Yeah, so we looked at very high level at this distinction between orchestration and choreography. Next question would be to how to actually implement that, to how to code that. And what we're seeing is that there are a couple of more low-level patterns that kind of support this architecture. And a couple of those would be, of course, to use messaging and use asynchronous interactions instead of synchronous ones. Those should be kind of obvious. But another one that's less well known and I want to discuss in a little bit more detail is called CQRS, Command Query Responsibility Segregation. Is anybody familiar with that already? Quite a lot of it.
Good stuff.
That's good stuff.
Yeah, we're getting there.
Yeah.
Yeah.
So we'll take it a little bit quicker then. So for those that don't know it yet, the easiest way to understand CQRS is by comparing it to a non-CQRS system. So in a non-CQRS system, you would have some domain model that's typically backed by some database, and then your client code interacts with that domain model, very high level architecture. And what often happens in these architectures is that the complexity of your domain grows as the application evolves. Then your queries will become more complex, they will become hard to maintain, they will become slow because they are so complex. And then you need to deal with that in some way. Especially with the performance. So that's where people are starting to introduce things like caching and materialized views and that kind of stuff. And that's really not a place where you want to be. That's not a nice maintainable solution and doesn't play well in those choreographed architectures. So the basic idea of CQRS is that you say, well, I'm not going to have a single domain model, but instead I'm going to split that. So I'm going to split it into one command side. So the command side just processes changes, but doesn't provide data to the end user, and one or more query sides. So the query sides give data to the end user's query results, but don't make any changes. So you get a segregation of those roles. Of course, to make that work, you need to keep the query side up to date with what happens on the command side. And the typical way of doing that is by raising events. So the command side would produce events, and the events get processed by the query side to update their own data models. So this introduces considerable complexity, of course. It's more complex than doing the thing to the left, so it should be justified, and you should get some benefits. But there are great benefits. So if you look at this in the context of having many microservices and letting them be autonomous, that's exactly what you're getting here. The command side and the query side, they are loosely coupled through exchange of events, and they have their own databases, so they can work without each other. And you can introduce new query sides reading the same events without modifying anything else. So you also get this agility if you use this kind of model. You're also totally free to choose database technology, and that's a pattern we see a lot. So this, on the command side, you would typically have something with high consistency guarantees, like a relational database or a dedicated event store. And on this side, you would use something that's optimized for the queries that you need to execute. So it might very well be an Elasticsearch if you want to do a full text search capability, or MongoDB if you want to serve entire documents to your end user, or maybe Neo4j if you want to establish some kind of graph querying capability. And using this basic CQRS pattern, you can really, in a very clean way, combine all those different technologies and still keep a sensible overall architecture. So there's some great benefits. One thing that's also often used in conjunction with CQRS is a pattern called event sourcing. It's logically a separate thing, but it's often used in conjunction. So the idea of event sourcing is that you have a particular architecture on how you store stuff on the command side, which is to store the state not as just the current state, but as a sequence of events that have occurred. So you keep full history of everything that happens. Conceptually, that's separate from CQRS, but there's a great match with CQRS because if you store data in that way, you cannot efficiently query it, so probably you're going to need to do CQRS-like stuff to still being able to efficiently perform queries if you use event sourcing. And on the other hand, if you have CQRS and you wish to initialize new read models, the easiest way to do so is if you have kept all the past events. So CQRS and event sourcing tend to be used in conjunction a lot. So this is where Axon Framework comes in. So Axon Framework is an open source Java framework established in 2010, so quite some time ago. And it started out as a CQRS framework for Java. So it's built on the CQRS principle, event sourcing, on domain-driven design, and on the notion of location transparency. These would be like the key ingredients of Axon. It was like a marginal thing, honestly, for the first couple of years, but it started to become really big. Also, if you look at the download numbers around 2014, 2015, exactly when the microservices trend began. So it was like people were rediscovering those concepts that were the foundation of Axon in the context of microservices. So if you would look at how Axon relates to the basic CQRS architecture, then in CQRS you're exchanging commands, events, and queries. And the key assumption of Axon is that you represent these as Java objects, so they're explicitly represented. So a command invocation is not just a method invocation, but there's an actual command object. These object gets passed around via buses, which are Java interfaces. And Axon takes care of correct addressing of those messages. So you don't have to do that yourself. The only thing that you do is add some handlers to particular methods that are designed to process commands, events, or queries. And then Axon makes sure that they get delivered. There's a lot more to say about it, but if you would just have 5 minutes to explain the framework, this would be the essence of it.
Let's see how you use it. Yeah. So applied in a domain like the blocks platform, what you can see is that we have some subdomains. So we have maybe starting on the left top, we have markets and quotes. This is where we actually give pricing data to the brokers. We have products and pricing. This is where we define our products and how we actually calculate the pricing. We define assets. That's the position that the platform has on, for example, banks and exchanges. And then we have actually the order subdomains where you issue orders. And broker account ledgers where you define your actual, the broker definitions and the ledgers which come with it, so where we actually register the transaction. If we zoom into one of these guys, for example, the broker account subdomain, you can see that such a subdomain is composed of typically, I would say, 3 modules, which are what you see there in the blue box is the account. So that would be really the command handling part. I don't know if it's very readable actually on the screen. Oh yeah, it's pretty good. And then you will have the query component or module. So think of these 3 blocks on below there, the yellow and the blue and the purple one as 3 microservices. Those 3 Spring Boot applications. Now the query side will have, as Frans just explained, will have his own database to actually persist the data received by events. The command handling side would typically apply a command which will transfer into an event into the event store. So that's the red database icon on top. So in this case, we have create an account, add an account product, or remove an account product, which will lead to certain events like account created or the product added to an account or removed, which will propagate further into the system on the event bus. So that's a typical subdomain, and if you actually look at the whole architecture or the complexity of the whole application, you will see that this is very repetitive. We see this a lot. It doesn't have to be, I mean, some of them don't have an aggregate side because they just produce an immutable object, so they don't really need to keep state. So we can persist them immediately, but typically it will look like this. One of the modules, I like to use the term module rather than microservice. I don't know how you feel about microservice, a term, but it's very debated. What's micro anyway, right? So what's the reference? Typically, well, Spring Boot module, it has very limited number of third-party dependencies. We do share some of the code. We use a monolithic, or we use a monorepo as said. So we have one Git repo where we have all the subdomains. And the reason we don't split out the Git repository yet is that it's actually just one team working on this. So, but you can imagine, for me, scaling Git repositories is very much connected to the number of teams working on it, where you don't really want to collide inside the same Git repository. So we do share a bit of code, like what you see here, Axon config and module, generic module configuration. But besides that, and it has obviously also dependency on Axon and Spring Boot, but besides that, it's very limited. And we actually, another cool thing we do, I think, is we work API specification first. So we use Swagger specification to write the REST controller specs, and then we actually generate the code from that, the controllers, but also the model definitions on that side, which gives us quite a uniform way to work. Now, if we actually look at a couple of subdomains working together, and I hope this is actually, it's quite small, but I'm trying to explain it. So on top you will have the order domain, and below you will have the account and ledger domain. And what I really want to highlight here is that when something happens in the account domain, it has an impact on the ledger domain. And when something happens in the order domain, it also has an impact on the ledger domain. So that's really the dance happening, right? It's a consequence of commands or intents happening in a certain subdomain, which will propagate back into the system. And maybe a better way to actually highlight this is through a sequence diagram. So what happens here is that when we get a request to create an account, a broker account, it will be received in the account command handler part. That's the blue part. It will be applied, and then there will be an account created event propagated to Axon. Axon will further broadcast that event to event handlers. So event handlers are registered into the Axon system and are well known to the system. And in this case, we actually have two other modules, query modules, listening to that event. That's the account query and the ledger query. The account query is interested, obviously, because it wants to build or it wants to persist the data which has, the account which has just been created. But the ledger query side is also interested because it also wants to actually create a ledger at that point in time in the query model and persist that as well. So here you see some of this dance happening, and if you would actually do this in a CRUD architecture, that means you would need to do 2 calls to 2 different services and compose actually how that should work. In this case, it kind of happens automatically. And then we have the next step, which is when an order comes in. So let's say somebody wants to buy Bitcoins for euros. So that's the way we define a product in the system. It has a left or from and a to, from euro to BTC. So create an order from euro to BTC. There is a certain quantity associated with both sides. And the order gets created. We actually produce an event for that order. This is an example of one of these cases where it's actually an immutable object. It's a one-off. It persists as event. It will be recorded in the event store of Axon and then propagated further back in the system and then catched, in this case, by the ledger query, which says, okay, so there is an order being created. Let me update the balance of the ledger. So I will plus the euros and minus the Bitcoins. So what you've seen here is a really concrete example of a dance happening. Now, what it means also, if you look on, let's say, on a data view of the system, is that the data which is persisted in the account query side, the account and the account products, and the data which is persisted in its own database in the order subdomain, will eventually become consistent also in the ledger, so will be propagated. So the whole system acts asynchronously, which is actually something you need to consider of. If you want to ask a query model, or you want to ask a certain question to either account or order or ledger in this case, you have to consider that it might actually have not propagated yet. So that's one thing you need to keep in mind. Now, this is a picture of, let's say, the overall architecture as it looks now. So you can actually see this dance, or this line. I don't know if it's actually visible, but you should see some lines between the subdomains. And in terms of dancing, then what you could start off with is maybe to define some products, right? They would start to dance, and then you would define an account and add those products to that account, which will propagate to the ledger, and then we will define crypto exchanges, which will allow us to receive some pricing data, of which we can issue a quote, which can then be translated into an order back into the system, which will lead to a balance update and maybe change our positions, which we have on the banks, etc. So what you end up with is a whole dancing architecture, and that's really the key of our message here. Let's move on to the operational side of things, which is hand over to Franspec, so the deployment stack.
Yeah. Yeah, so we've now talked a little bit about how to architect the application, how to use Axon Framework, how to do the dancing. But then, of course, we need to actually run that on some infrastructure and need to get those microservices alive and talking to one another. So let's have a look at how to do that. So first of all, if you look at Axon Framework-based applications in general, they don't force any type of infrastructure upon your project. So the basic architecture of Axon applications is that you have a bus, or actually 3 buses. There's one for events, one for commands, and one for queries. Handler methods that need to process one of these, they are registered to that bus. And then application code that wants to send a message sends it to the bus. And then Axon takes care of the rest. The bus is very much an abstract thing, so you can have many different implementations of that. Christophe just mentioned that we generally advise to not start with microservices, and that's based on this idea. So some of those bus implementations that are available actually don't do any type of external messaging on the network. They just live inside the JVM. And then you can later on replace that thing by a bus implementation that does actually use external messaging, and it doesn't influence the rest of your application code. So there's no real need to start working with microservices from day one, because you have the option to very easily go to an architecture like that when you need it, and it wouldn't change how the rest of the application works. One thing to take into account is that if you want to have that option, it's useful to start with at least asynchronous coupling inside your JVM from day one, so you don't get that change if you change to an actual messaging system. So there's quite a large range of buses available within Axon itself. Of course, AMQP and Spring Cloud, and actually the next version will have a Kafka integration as well, because it was asked for a lot. Yeah. Or you can create your own bus implementations if you want to do something else. Because of this architecture, there's no infrastructure that Axon really demands.
Could even work in a car with a CAN bus, maybe.
It could, yeah.
I don't know.
Yeah. Actually, Trifork Eindhoven uses it to communicate with bikes, with e-bikes. Oh. And they have their own transport protocol for that as well.
Cool.
Yeah. Now, if you think about what those buses should do, it's important to note that there are specific requirements on the messaging. So we've seen that there are these 3 types of messages: commands, events, and queries. And event transmission between components is probably the most obvious thing to do and most familiar, because that's like pops up. Someone publishes an event, and all other handlers can receive that event and process it. And there's not much more to it. If you look at those other 2 types of messages, commands and queries, they look very different. So commands are not published to everybody. Commands need to be handled exactly once. And then the person or the service sending that command needs to have a confirmation that it was approved or not. And in terms of load balancing and routing, what you like to see with commands is they are consistently routed to the same handler instance, so that this handler instance can do some useful caching there. So you don't have to read objects from disk all the time. Queries are kind of like commands, but have some different routing patterns. So instead of doing consistent routing and optimizing for caching, typically you're doing load balancing there. And in addition to the pattern where query has to be handled exactly once, we also see patterns where there is a scatter-gather thing going on. So you have multiple instances of a particular handler, and you want to have the answers from all of those, and then pick the best one. So for instance, you could have a pricing module with standard pricing, but then a specific summer discount pricing, and a front-end application would get results from both and then make a decision. So that's a scatter-gather pattern that we see quite a lot. So from any kind of infrastructure running Axonic in a distributed way and doing the messaging, you would like to be able to do all of these things and not have just the middle familiar pops up type messaging. So in addition, of course, the messaging should be very scalable, and you want to have multiple instances of every node and easy to configure. So for this purpose, we built a component called Axon Hub. So Axon Hub is a separate component from Axon Framework. Axon Framework is something you would include as a library, and Axon Hub is a separate runtime component. And it essentially is a messaging platform that's optimized for this specific case. So it understands the differences between commands, events, and queries, how to route them, does automatic discovery. So it's just a very easy way of getting a distributed Axon system. So logically it looks like this. So you have all those dancing services collaborate with one another, but on the network level, what happens is they all communicate with Axon Hub technically using gRPC connections. Messages flow both ways between the services and Axon Hub, and logically you get the picture to the left. So that's the basic idea of Axon Hub. Now looking at how to run this, of course if you use microservices, you're going to need to have some isolation, but you don't want to have full fat VMs for every microservice. So most of our customers nowadays are using Docker containers for that. And then since you're going to have many and you want to run them on infrastructure and automatically deploy them in the right scale, most of our customers nowadays are using Kubernetes to do that as well. It's a very popular platform, also used by Blocks, but many other customers from Axon. And in this context, you would like to run the Axon Hub solution on Kubernetes as well, just to have a single deployment platform. So what you get then in an architecture term is something like this. So you have a Kubernetes cluster running a number of Kubernetes nodes that do the actual work. Then for the microservices or modules, as Christoph likes to call them, you define Kubernetes deployments. Deployments are the simplest type of Kubernetes controller that does nothing more than just say, well, you have an arbitrary number of instances of a particular service, and they can run in parallel. So you don't need to, in this architecture, you don't need to make those services discoverable in any kind of way. You're putting a load balancer in front of them. Because what you do, you let those services communicate with Axon Hub, and then Axon and Axon Hub take care of those kinds of aspects like routing and load balancing. So the deployment of those modules is really easy. Looking at Axon Hub itself, that's a little bit more complex because that's a cluster for high availability and load balancing. So the various module instances can connect to several Axon Hub instances, and they will communicate between each other. And if one Axon Hub goes down, all the connections will fall over to the other one. And this doesn't work if you would use the most naive Kubernetes deployment controller, because then those pods or containers, they are very ephemeral, they can get destroyed, and they don't have any identity, and you don't get a stable cluster. Now, luckily, Kubernetes has a specific feature for that called stateful set. So stateful set is like having multiple instances of a particular pod, but they do have a stable network identity. They do get a persistent storage. And they are being built up and scaled down again in a predictable order. And this thing allows us to easily build up a cluster in Kubernetes, make sure it functions reliably, and all the messaging works. So that's the basic picture. Let's have a look at how it looks like for real.
Yeah, and actually I remember very well, Frans, when you showed up at the office and presenting Axon Hub for the first time. And actually prior to using Axon Hub, we were using especially on the command side, we had this distributed command bus, and then we had to implement discovery with using Spring Cloud and Consul. So we had Consul running as well, which is didn't feel very right because Kubernetes itself has discovery mechanisms in it. And it all felt a little bit shaky and a bit complex. And Axon Hub has really kind of flattened that. It's just no worry anymore. And our services appear, and I will actually show how it looks like later on. So this is our deployment pipeline, and we actually build all these modules, what you see here. Sometimes we actually bundle some of the low traffic modules, like creating accounts and products. It's not going to be very high modules, so we just put them together. We don't want to have separate Kubernetes pods for that. We actually only build and deploy when there is actually a change, so we detect the change. We use Helm. Who's familiar with Helm? You raise your hand. Only a few hands, and that's my colleagues again. Oh, no, some other. Helm is actually, I think it's super cool. It's a package manager for Kubernetes applications, and there is actually, why I'm just going to show it right now. We can talk about it forever. Well, that's my mailbox. Sorry about that. So you can go to kubeapps.com and explore Kubernetes applications which are packaged as Helm charts. So the packaging name is called a chart. And let's say you want to deploy Postgres in Kubernetes, then there is a chart for that. And you can actually, in your build pipeline, that's what we do. We do Helm install, and then we reference the chart, or we actually make a copy of the chart in our own chart repository. And kadang, it's going to be deployed. And there are ways to actually configure the properties, etc. So that's really, really, really cool. So that's, we build first, and then we actually deploy the environment. So the environment is the dependencies, let's say the kube charts, which we need to have in the system, like AxonDB, Axon Hub, Postgres, and a few other charts we are using. Then we actually use Helm also to deploy the actual service which we'll build before. So Docker image gets created, pushed up in a registry, and deployed here. And after that, we run all kinds of API tests against the system. And we have more plans. We're more ambitious. We want to do heavy load testing, chaos engineering, and stuff like that. But we haven't come to that yet. I mentioned we do API specification first, and as you saw, that the purple modules are all really REST modules. So basically modules exposing a REST API to the outside world, which have their own specification. And that means that you end up with a lot of YAML or OS spec files which are scattered in the system. And we did something pretty cool, I think, which is to actually deploy a Swagger UI component in the system which aggregates all these YAML files into one. And it's a little bit off topic, but I think it's so cool I just want to show you. So the account product domain exposes this API, and another domain will expose this API, etc. So this is one way to aggregate all your different API specs into one place and be consumed by clients. Next is the actual Kubernetes cluster itself. How many time-wise?
I think 8 minutes.
8 minutes. Okay, let's wrap it up a little bit. So this is a screenshot of a Kubernetes cluster. I mean, it's not super exciting, but it's pretty cool that you can actually see all your pods running together. And I think it's initially quite complex to set up Kubernetes together with Axon and make everything work, especially when you redeploy. So if you have blue-green deployments in Kubernetes, you want the system to stay stable. But lately, I think we managed to really stabilize it. So every deploy, every build actually, or pull request merge into master gets deployed, will lead to an upgrade in one or more of the modules, and the system keeps running. Then we can also have another look at Axon Hub. I have a screenshot, but it's better live, I think. So this is the Axon Hub comes with a user interface. It shows you initially the number of events. Snapshot we haven't mentioned, but you can actually, well, no, I'm not going to skip that for now. We have and the number of commands and the number of queries executed on the system. Then you get an architecture overview. So this is the logical connection of all the services which are connected to Axon Hub. And you can even zoom into it and see which command are actually can be processed specifically by this module. And if there is a module which does some query, you can actually see the queries. And then you also see the what we call the tracking processes. So that's the way, that's the mechanism actually to pull in events. There's different ways to do it, and you can see that here. You can see all the commands registered in the system, all the queries registered in the system. So it gives you a really, really nice overview of the whole system. And well, I mean, when something doesn't work in the application, first thing I look at is Axon Hub. I want to see that my module actually shows up here, that the commands are registered or the queries are registered. That gives me a very good indication that if it's not there, then that's the first thing we should work on, right? What you see here, that's at Axon Hub, there's only one instance deployed. This is because this is our test environment, and when we deploy next to staging, we will have a cluster mode, and this will be more demanding when it comes to operational aspects. I think that's it. Do we have time for some question?
I think so.
Yeah. Okay. Thank you very much. We have some time for questions now, I guess. There's one over there.
So the question is, how would you implement a management report for a CQRS system with event sourcing?
You want to take that one? It's theoretical. I have some ideas.
Yeah, so the nice thing about CQRS and event sourcing is that you're totally free to do whatever you want on the query side. So there's nothing enforced there in terms of technologies. There's just events coming in, and then based on that, you update the data store that you have. So it's perfectly suitable for any kind of management reporting there, and you can just pick and choose the information system that you would prefer. So is there any specific concern you would have there?
Okay.
Yeah, right.
So this has to do with scalability of the event store.
Yeah. So what we would see there is, with our customers, is two different patterns. So one is that they would use a single event store, making that very scalable. We have some customers processing up to 10,000 or more events per second, but then still using a single event store. The other pattern that we see is that you actually use different event stores for the different commands, or for different aggregates. But then you still combine them together. So you can, that's also possible in Axon, define event sources that actually read from multiple event streams, and then you can project all of that into a single reporting database. One challenge that you do have there is that if you have large numbers of events, just the process of projecting those events into a read model becomes a bottleneck. What we do there is enable multi-threaded processing there, and it's actually quite a new feature in Axon because it's difficult. And the reason why it's difficult is that if you do multi-threaded event processing in a read model, you may actually be processing events out of order. Like if you do an insert and then an update, and those get mixed up, it simply doesn't work. So what we do there is that we have sequencing policies, and the sequencing policies define which events have to be processed in order on the same thread, guaranteed. And because we have those, we can now deliver multi-threaded event processing, and we can process vast amounts of events per second.
But keep in mind that something maybe we didn't explicitly mention, but let's say the event store, so your history of events, that's the business value you have. And I don't mind actually throwing away all the query databases, throwing away all the data, because what I can do is replay all the events and they will be repopulated. So that's the way there's another way you can look at the system. And it actually also allows you to update your business logic in your query. You just replay the events and do something else with it. So it's a very, very powerful way to deal with this.
So there's a couple of things there. So first of all, we always recommend that to have your events being very close to the business. So it should be business events. And the idea is that if your technology changes, it shouldn't change the fact that these events have taken place in the past. So that would keep your events relatively stable. Another thing that we recommend is to choose your serialization mechanism in such a way that you can do stuff like add new data to event structures while still keeping the ability to read the old events. So if somehow these things don't work out and you still do need to actually make a change to events, one mechanism that's present in Axon is called upcasters. So these can be configured to read one or more like old style events and then produce one or more like new style events from that. So in your case, you mentioned the case that a particular event was needed now and wasn't present in the past. So if in some way it could be derived from the data that you do have, this is the way you could do it. Of course, if the event represents something that simply wasn't recorded and you want to know now what happened in the past but you didn't remember, that's, well, that doesn't have a solution.
Yeah.
Yeah.
What I understood from that, it's not something I experienced myself, but I've been discussing Axon with former colleagues, and they experienced this, that they needed information from different events and that they couldn't replay.
Yeah. So one of the beauty of we talked about CQRS and event sourcing and how they collaborate. Of course, if you do event sourcing on your command side, then by definition, you have recorded all information. If you don't use event sourcing in your command side, it could be the case that you simply didn't publish certain events. But if your aggregates are defined by their events, then there's nothing, by definition, there's no information that's missing.
I think it's a luxury problem, actually, because, I mean, before that, you just had state in the database, and you didn't know where it came from, right? And now you have a history to actually show and prove that the state in my system came from that history, and still we're not happy, right? So, but we're getting there.
Well, it helps a lot, but if your new model requires certain events to take place and you don't have those events, then
No, but you do have a point. Yeah, you have a point, definitely, and yeah, I think it also has to do with tooling. I mean, maybe you need some migration tooling to change your history. It's tricky.
Yeah,
Let's rewrite history.
Yeah.
All right. Any more questions? Do we have time for questions? No?
Yeah, I think we can do one more.
How would you compare a distributed event bus, as I expected it was going, like RabbitMQ or Kafka, with tracking event processors in distinct applications, as you seem to have now?
That's a question for you, Frans. This is the architecture of Axon Hub versus the...
Try to rephrase the question. So it's...
Oh.
Yeah, exactly. So you're asking how does distributed event processing with Kafka or AMQP or anything like that compare to the event processing that we're doing in Axon? Is that what we're doing?
No, I expected that Axon Hub was comparable with a distributed event bus, like over RabbitMQ or JGroups or Kafka. In the end, it turned out with separate applications that have their own tracking event processor. At least that's how I understood it.
Right, yeah.
So I was wondering how to compare those. If you have the ability to use Kafka to spread your events,
right? Yeah, so
would you prefer that or the opposite?
Yeah, so it's about the comparison between Axon Hub, Kafka, the tracking event processors. It's kind of like a broad question, right? But we see that most of our Axon Framework users also happen to use Kafka somewhere in their architecture, so in that sense it's not a competing thing. So Axon Hub works very well between Axon components, knowing how to route commands, events, and queries in a distinct way, and it can do event sourcing efficiently. Kafka works very well for processing very large amounts of events, also for replaying all of them into a new read model. It works perfectly well. You can store your events indefinitely. It's not so much suitable for event sourcing because it doesn't have an efficient way of getting the events relating to a particular aggregate back in memory. So that's why it's not really an alternative. So what we're seeing typically in these architectures is that Kafka is being used to connect Axon systems to the outside world or to other applications. And then Axon Hub, if used, is being used for the communication within the Axon system. Yeah. If you look at the tracking event processors, what they do in Axon is that they read events from a given point in time. So they keep track of where they are in the event stream. That means that tracking event processors are by definition not compatible with traditional messaging infrastructure like AMQP. So the way they operate normally, if you would not use Axon Hub, is that tracking event processors would be polling a database for new events, and the events would all be stored and then and therefore can be replayed from any given point in time. And if you would use Axon Hub, the way that would work is that behind Axon Hub there is also an event store, and the tracking event processors would read those events through Axon Hub. Yep. Axon Hub itself is stateless. Does that answer your question?
I think one of the things I realized also is that I mean, Axon Hub really abstracts away a lot of infrastructure configuration, right? So suddenly you're actually writing business logic instead of configuring Hystrix and RabbitMQ and all that crap, you know. So I think for us it has great value. It allows you to park all the infrastructure side. It's taken care of. That's the way I look at it. And I just define query handlers, command handlers, event handlers where I need them, and things just work and happen. So that's really the cool thing about it.
I think we should now let you go before lunch is all eaten.
Oh, we start already. Thank you very much.